Hello guys, you're welcome to this channel and thanks for coming back again if you're a subscriber, and if you're yet to subscribe you can click on the subscribe button and also on the notification bell that will tell you when we drop our video. So we want to discuss a topic called spectroscopy in this video, and here we are going to analyze certain things about spectroscopy, the type, and also explore Beer's law, Lambert's law, which was coined together to get the beer-lambert law. So we're going to start with explanation of what spectroscopy is, and then we analyze certain things about it. Okay, now from the word spectra we could generate spectroscopy. Yeah, spectra, they are lights that are produced as a result of property of some matter in terms of absorbing or emitting energies. Okay, let's just start by explaining what spectroscopy is, then we can proceed to what spectras or whatever the case might be. So the word spectroscopy deals with the study of the electromagnetic radiation interaction with matter. Or let me put it this way, light is an electromagnetic radiation, so therefore spectroscopy is the study of light interaction with matter. So light really interacts with matter in a lot of ways, and this is going to talk about the interaction with matter at the chemical level. Now, that is what spectroscopy is. Now, I need to differentiate between spectroscopy, spectrophotometer, and photometer itself. Okay, let me say spectrophotometry and photometer, or spectrophotometer. Okay, photometer and then spectrophotometer. Okay, let's put it this way. So now we already understand that spectroscopy is study of light interaction with matter. Now spectrophotometry is any method or any technique that uses light to analyze samples or to measure concentration of samples. Okay, concentration of colored solution in chemistry to be precise. So take for instance, you are taking a soft drink and it has a characteristic dark color, so you can use spectrophotometry as a technique to measure the concentration of that solution or mixture. So any technique that involves not just measurement of concentration of solution, at the same time you can use it to analyze or for structural elucidation. So now photometer is just like a device that produces a light of specific wavelength range. Now I am going to shed more light on all this. Then spectrophotometer is when you are using the machine to actually perform spectrophotometry. So that is just the gap between them. So now, what do we understand by all these and how do they relate with spectroscopy? Because the actual concept is spectroscopy, so which is the study of light interaction with matter. Now let's talk about the property of light first. Light is a wave and also behave like particle, but let us consider the wave property of light. So when light travels, it travels with certain frequency and then wavelength. So it also consists of particles called photon. The particles in light are called photon, and each photon carries a certain amount of energy. So now this energy is what we are using in analysis of sample when it comes to analytical chemistry. So now light has wavelengths. This is wavelength. Now, the inverse of this wavelength is called wave number. and we have frequency of the light. Frequency. Then at the same time we have, this is frequency, and at the same time we have c, which is the velocity of light, so speed of light. Good. So this is one thing we need to know, it's property of light. So all these are all together are the main reason why light carries energy, because the energy carried by light is equals to, you can use hc over lambda. So which in other way you can also write them in form of E equals hf. Good. So this is part of it. So this consists of two formulas. Let's say that. So and then you can rewrite this in any form, maybe hc over 1 over hc multiplied by 1 over wavelength. So that will give you wave number, and wave number is symbolized with this, something like this, v, and you put a dash on it. So that is wave number. So this is property of light, and this equation shows the energy carried by light particle. So understanding this is quite prerequisite to understanding spectroscopy. Now, talking about light again, white light consists of more than one type of colors, or let's say more than one type of radiation. So we have them arranged as radio wave, microwave, infrared rays, visible light rays, ultraviolet ray, X-ray, and gamma ray. Okay, these are the series of electromagnetic radiation, which we call them electromagnetic spectrum, because they are spectrum because each one of them have a line, or let's say a spectral line they create due to difference in their frequencies and wavelengths. So they arrange them according to frequency and wavelength. This one has the shortest wavelength but very high frequency, and at the same time it has the highest penetrating power compared to the rest. So now, analyzing the relationship between the interaction of this light with matter in analytical chemistry, we use this light to measure the concentration of colored sample or colored solution, and at the same time we use it for structural elucidation. And this is because every molecules at the atomic level, we understand that electrons can gain energy and jump from lower energy states to higher energy states. It does not restrict to only electron alone. It also happens in molecule, especially organic compounds, because the part of organic compound that could absorb light and emit light, the most part are the functional group, because they are the active parts of the compound, and then we call them chromophore, spelled chromophore. So those are the active parts of a molecule that can actually absorb light and emit light. So the absorption of light based on each chromophore, like each chromophore has a certain amount of energy they need in order for them to be excited. So we believe that each chromophore, when they absorb light, they jump from the lower energy to higher energy. So the equivalent amount of energy they absorb is different from one another. So which means that the type of radiation that could be used to analyze each sample can also vary, because each radiation has a particular wavelength. So in performing any analysis in spectroscopy, the light must be monochromatic. However, even if it is heterogeneous, we have some properties we can discuss about the heterogeneous light too. So when you say monochromatic light, it means the light will have a specific wavelength range, so that we can easily deduce which of the functional group or chromophore is present, because each chromophore or functional group absorbs light at certain amount, at a required amount of energy, which is associated with the wavelength equation I mentioned. So the specific wavelength range will make us trace the amount of energy required, and that will make us trace which functional group might be present in the substance. So that is for structural elucidation and structural analysis. And for determination of concentration is quite simpler than structural elucidation. However, we do not have one type of spectroscopy, but all the type of spectroscopy we have is based on two things: the light absorbed by chromophore, or the light emitted by chromophore. Okay, let's take it this way. Chromophore is either absorbing light, so they create absorption spectra. Absorption spectra. This is plural of spectrum. Then, when they absorb energy, just like whatever you throw up must come down, that's law of gravity. So when they absorb energy, they still lose that energy as time goes on and then go back to the ground state. So now the energy loss, while losing the energy and they are moving back to the ground state, they create a spectral line too, which we call emission spectra. Emission spectra. So now we can use the amount of energy absorbed to analyze sample in organic chemistry and also determine concentration, and we can also use emission. So we have different type of techniques or spectroscopy that make use of absorption spectra, and we have the ones that you make use of emission. So now, for instance, for the absorption spectra, which we call absorption spectroscopy. So we have about 4 spectroscopy that make use of absorption. So we have the UV spectroscopy. Now, UV spectroscopy, a machine that is used to perform it is called UV spectrophotometer. You know, UV spectrophotometry is the process of, or is a technique of using UV spectrophotometer to analyze a solution or sample. Now, UV spectroscopy is a general term that covers the spectrometry and then the usage of the spectrometer, which is UV spectrophotometer. So let's move on. That's UV spectroscopy. So UV is ultraviolet light spectroscopy. Then we have infrared spectroscopy. Infrared spectroscopy. So this is IR spectroscopy. Then we have NMR, which is called nuclear magnetic resonance. Nuclear magnetic resonance spectroscopy. And we have mass spectrometry. Mass spectrometry. So these 4 make use of the property of absorption of energy, light energy, by organic samples to analyze them, to determine their concentration, to determine their structural elucidation. However, this one is best for determination of concentration of colored solution. This one is best for structural elucidation. So we will make other videos in analyzing one of them, each one of them. So NMR and mass spectrometry, they are also very good technique. So now, these are based on absorption spectroscopy. Now we have the ones that are based on emission spectroscopy. We'll talk about atomic emission spectroscopy. There is a device that is called atomic emission spectrophotometer, so that can be used directly. Then we have atomic fluorescence spectroscopy, and we have the atomic flame photometer. So let's just put it flame photometer or flame photometry. So flame photometer is the machine. So while flame photometry is the technique, then AES, that is atomic emission spectrometry, or spectroscopy is the technique. Meanwhile, atomic emission spectrophotometer is the device to perform the technique. So that is how it is. So these three that I listed here are making use of the emission property of those organic compound, the active part of the organic compound, which I called chromophore, to analyze them. And then why this one make use of the absorption energy. Okay, good. We have analyzed this to an extent, and we have a broad sense of it because it's a wide concept. We need to discuss each one of them. So now, there is a part I really want to touch, that is talking about Beer's law and Lambert's law, which we call together beer-lambert law. So these are two laws but combined to be one. Now, in this analysis, let's take for instance, we are about to determine the concentration of a colored solution. We are passing light through it, and there are some certain properties or certain things that will happen as a result of that. Okay, let's explore that. Let's move to Beer's law and Lambert's law. So from there we continue in the next video. So now, let's start with Lambert's law. So what Lambert did was he tried to establish the relationship between light, a monochromatic light, passing through a medium, a transparent medium like glass. Okay, if you have, for instance, you want to analyze a colored solution, maybe to determine the concentration, at least you have to put the color solution in a container. So the container has to be transparent. So there is a relationship between the light passing through the container ordinarily. Then also we have relationship between the intensity of the light passing through the content. So we are joining the two together because the content, the liquid is actually inside the container. So Lambert's law is establishing the relationship between the intensity of the light and the thickness of that medium, which is the container. For instance, in UV spectrophotometer, when you are performing UV spectrophotometry, there is the machine in that's UV spectrophotometer. The content you are putting into, you are analyzing, will be placed inside, will be poured into a container. They call it cuvette. So this cuvette is a transparent glass. So it's a glass material. So, and however, the container could be any material. So which means certain things we need to be discussed about the material and the thickness of the material. So Lambert's law established the difference between the material, that is the transparent material, without including the solution in it. So what Lambert's law states is that when light, a monochromatic light, passes through a transparent medium, the rate of decrease in intensity of the light with the thickness of that medium is directly proportional to the intensity of the light. So that simplifies that, which means the thickness of the container also depends on the intensity of the light transmitting, or the intensity of the light passing through the container depends on the thickness of the material as well. So it's simply like if you are using different materials, and you are varying the thickness. If the thickness of the materials increase arithmetically, the rate of decrease in intensity of light will decrease exponentially. Okay, if it's the thickness decrease arithmetically, then the intensity of the light decreases exponentially. That's the meaning, since they are directly proportional. So in that wise, we establish Lambert's law. Now, we need to analyze certain things here to talk about two things. They call it transmittance. When light passes through the container like that, and also the content, but let's start with the container, there is a fraction of light that is absorbed by the container as a result of its thickness, while there is a fraction of light that will be reflected there will be slight reflection, which is always very low percentage. Then there will be fraction of light that will successfully pass through the material and get to the other side. That means the one transmitted. So let's analyze that. So if this is the initial intensity of light from the machine, from the source. So let's say this is the light intensity from. Now, by the time the light passes through the container, there is a reduction in the intensity. So which means fraction of it would be absorbed, fraction of it will be transmitted. So which means the intensity that is transmitted, let's call this light intensity transmitted. Light intensity transmitted. So this is the light intensity that is transmitted. So let's consider the fraction. So which means this is part of the fraction, that part of the fraction of the what's it called, the original light coming at the original intensity of the light coming from the source. Okay, let's consider the reflection also. So that is light intensity reflected. Light intensity reflected. So which means if we are to look at this relation, we would have then plus one more thing, the light intensity absorbed, because let's call this light intensity absorbed. So a fraction of the light will be absorbed, a fraction of the light will reflect, and a fraction of light will be equally transmitted. So we can easily eliminate this. I think a lot of machines are built to eliminate this, especially if you are talking about glass face. If the material is a glass material, so this will always be eliminated using a control. So there is always control in those machines that will eliminate reflection. So which means the equation simplifies to amount of light transmitted plus the amount of light absorbed. Now there is something called transmittance. Transmittance T is the fraction of light that is transmitted. So which means transmittance is the fraction, the intensity of light transmitted over the intensity of light that comes from the source. So this is it. This is the value for transmittance T. Now there is also absorbance. Absorbance A is negative logarithm of transmittance. Negative logarithm of transmittance is absorbance. So we have established this relationship and we have explained Lambert's law. Now let's move to Beer's law. Beer's law. Now, for Beer's law, Beer's law established the relationship between the content of the container now and the intensity of light. So Beer's law did similar research just like Lambert did. Beer did similar research just like Lambert did, So that established Beer's law. So it says that the decrease in intensity of the light, the rate of decrease in intensity of the light with respect to the concentration of the colored solution is directly proportional to the intensity of the light. So which means if the concentration of the solution, the colored solution, decreases arithmetically, which means the intensity of light decreases exponentially. So that is Beer's law. So we can summarize Beer's law that it's just telling us that intensity of light decreases exponentially with respect to decrease in the concentration of the solution. So that is Beer's law. So Beer's law established the relationship between intensity of light and concentration of solution. Meanwhile, Lambert's law explain the changing intensity of light with respect to thickness of the path length through which the light pass. So now, if this is the container now, so Beer's law is just talking about the thickness of this container, the path length. Meanwhile, Lambert's law talks about the thickness of the container. So Beer's law talk about the concentration here. So which means for a deeper solution, there will be a more fraction of light absorbed. So the color of the solution can also get deeper or less deeper. So, and that will also affect the fraction of light that is transmitted or absorbed. So that is Beer's law. So when we match the two together to get Beer-Lambert's law, so we just say that absorbance, the Beer-Lambert's law, is just the combination of the two laws. So this one tells us that the absorbance, the amount of the absorbance of light is proportional to the concentration. So where C is concentration of solution, of the colored solution. So when we want to introduce constants here, we introduce the path length of the container, and there is another constant called absorptivity. So we have this C L. So this is C. So this is called molar absorptivity. C is concentration as usual. So L is what? The thickness or the path length. The path length of the light. So this is Beer-Lambert's law. So which means we can represent Beer-Lambert's law graphically. It's going to be a linear graph, but the linearity of Beer-Lambert's law is limited. So which means the law has limitations, and it could have a positive deviation or negative deviation. So let's take, for instance, you have the graph of this is absorbance, this is concentration. So the graph goes like this. So this is completely linear. So you can have a positive deviation and a negative deviation. And what will cause all this? At higher concentration, very high concentration, the law may not act. Yes, the law may not act. Then you can also have particles in the solution, so that will cause deviation also. We have a lot of factors that serve as limitations to Beer-Lambert's law. So, but still, at lower concentration, Beer-Lambert's law is still being used in quality assurance. Take for instance, in the production of take for instance a soft drink. If you always want the production to be uniform, all you just need to do is the previous product, put it in the cuvette, test the fraction of light transmitted and all that. So the new one you want to produce should also have the same value. So you don't have to stress yourself. You just have to keep doing what you're doing until you check and you see that the fraction of light transmitted here equals fraction of light transmitted there, or whatever, and then you would get the same concentration without no stress. So this could be used generally in all the spectroscopy, but I think we have about some limitations to it, like I've mentioned few. So we can explore more about it and then talk about more of it. So let's call it a day. Let's stop here for this video, so we can continue from there in another video. So we discuss more about spectroscopy. It's actually a wide concept, because if we are to explain more on UV spectroscopy, IR, AES, and so on, we are going to go a long way. So let's just establish the idea and understand beer-lambert's law. Thanks for watching. Please subscribe to the channel. It's free, and endeavor to share the video. Thank you.